We will now discuss 3 questions from the section Linear Algebra that appeared in the joint admission test for master's examination, that is JAM Mathematics 2022 examination. We first take up the first question, which is based on powers of matrices, and is a multiple choice question for 1 mark. Consider the 2 by 2 matrix M is equal to, first row, 1 1 1 0 belongs to M2 over R. If M power 8 multiplied by the column vector 1 0 is equal to the column vector x y, then x is equal to. We are given 4 options here. Now we have the given matrix M, first row 2 by 2 matrix, first row 1 1 1 0 belongs to M2 over R, the vector space of all 2 by 2 matrices over the real field. Now to obtain M power 8, first we take M square, then M power 4, then we compute M power 8. So to get M square, multiply M with M. M is here, multiply, you will get M square as 2111. M power 4, M square multiplied with it by itself, M square multiplied by itself will give you 5332. M power 8, we get multiplying M power 4 with itself. Then we get M power 8 as a 2 by 2 matrix, 34 21 first row, 21 13 second row. Now it is given M power 8 multiplied by the column vector 1 0 is equal to the column vector x y. So M power 8 is written here 1 0, and that is x comma y. When you multiply M power 8 with the column vector 1 0, you will get a column vector 34 21 is equal to the column vector x y. So equating the corresponding entries, we get x is equal to 34. The answer to this question is 34, that is option C. And it is a very simple, straightforward question. We move to the second question. It's again a multiple choice question for 1 mark, and it is based on the concept of the rank of a matrix. The rank of a 4 by 6 matrix, this is the 4 by 6 matrix given with the entries in R is, the 4 options are here. Right. Let's call this matrix 4 by 6 matrix as capital M. Agreed. And we know the rank of M is less than or equal to the minimum of the number of rows, comma number of columns. So the rank of M is less than or equal to minimum of 4 comma 6, that is 4. Now our aim is to reduce this matrix M into echelon form, then find out its rank. Agreed. We first take the matrix, this is the matrix, and we want to make this entry 0. To do so, from the entries of the second row, subtract the entries of the first row and write in the place of the second row. That's what we do precisely. M. On M, we perform this elementary row operation R2 implies R2 minus R1. In the place of R2, we write R2 minus R1. Then the changed second row is this one. Now, in this matrix, we want to make this entry 0. To get an echelon form, we make this one. That means to the entries of third row, add the entries of the second row and write it in the place of third row. That is, R3 is, in the place of R3 we write R3 plus R2. So when you add these entries have become this one. The remaining ones are same. The remaining ones are same. Now we want to make this entry, that is third row, fourth row, third column entry 0. To do so, we write in the place of R4, R4 plus R3. Then R4 is get changed to here. Thus we got an echelon along the diagonal. Along the diagonal, the pivots are 1, minus 1, minus 1, 2. It is precisely echelon form. And the rank of this matrix M is given by the number of non-zero rows that are present in the echelon form of the matrix N. The number of non-zero rows that are present in the echelon form are 4. First row, second row, third row, fourth row, 4. Therefore, the rank of M is 4. So let's look at our options. The answer 4 appears against option D. Therefore, the answer to this question is option D. This is again a simple, straightforward question. We move to the next question, question number 3. And this question is based on the concept of subspace. And it is again a multiple choice question for 1 mark. Let V be the real vector space consisting of all polynomials of one variable with real coefficients and having degree at most 6 together with 0 polynomial. That means you are considering the vector space of all polynomials of degree 6 at most 6 with real coefficients. Such a vector space, the dimension will be 6. Then which of the following is true? The first one is the set of all those polynomials belongs to V whose value at 1 by 2 is not a rational number, is a subspace for V. All polynomials belongs to V, its value at 1 by 2 is 1, is a subspace of V. And all those polynomials of V whose value at 1 by 2 is equal to the value of that polynomial at 1 is a subspace of V. D. All those polynomials of V whose derivative at 1 by 2 is 1. And note down that the derivative of a polynomial is again a polynomial. And if you take a polynomial of degree 6, its derivative is a polynomial of degree 5. If you take a polynomial of degree 5, then its derivative will be a polynomial of degree 4. The degree is dropped by 1. Right, we discuss the solution here. So the options are here. Now we have V is the set of all polynomials a0 plus a1x plus a2x square plus so on and so forth an x to the power of n, where n less than or equal to 6, because the degree is at most to 6. Ai's, the coefficients are all coming from the real field for 1 less than or I less than or equal to n. It is a vector space over the field of real numbers, and its dimension is 6. It's a very well known result. And we know that every vector space possesses the additive identity, and in the case of this vector space of polynomials of degree at most to 6, the additive identity is the 0 polynomial denoted by 0. How the 0 polynomial will look like? 0 plus 0 times x plus 0 times x square plus so on and so forth, 0 times x to the power of 6. Right, and every subspace is also a vector space. Therefore, the additive identity must belong to every subspace. So 0 belongs to every subspace of V. And further, the value of the 0 polynomial at any x belongs to R is 0. So in the 0 polynomial, wherever there, so the coefficients are being 0, So 0 plus 0 times x plus 0 times x square plus 0 times plus so on so forth 0 times x to the power of 6 is 0, obviously, for any x belongs to R. Agreed. Agreed. Therefore, these are all polynomials whose values at 1 by 2 are to be found. Therefore, 0, the 0 polynomial at 1 by 2 also gives 0. And note down, the 0 is a rational number. But in option 1, it is given 0 of 1 by 2 is not a rational number. Therefore, the option A is not true. Option A, let us call the set that is given in option A as U. And now 0 at 1 by 2, 0 polynomial at 1 by 2 is 0, which belongs to Q, but here it is given it does not belong to Q. That means it is not a rational number, which is not true. It is a rational number. Therefore, this U is not a subspace of V. Not a subspace of V. By a similar argument, in the case of option B, 0 of half is 0 and is equal to 1 is not true. 0 is not equal to 1. Therefore, option B is also not a subspace. In the case of option D, if you take the 0 polynomial, its derivative is also a 0 polynomial. And that 0 polynomial at 1 by 2 is 1 is also not true, because after differentiating the 0 polynomial, you will once again get a 0 polynomial of degree less by 1, and its value at 1 by 2 is 0, but it is given to be 1. Therefore, it is not a subspace. So thus, the option A is not true. By similar arguments, you can show option B and option D are not true. So therefore, the answer is option C. But I will show you how this is a subspace. Agreed. So let us call this as the subset W. W is equal to the set of all polynomials belongs to V, whose value at 1 by 2 is the value of the polynomial at 1. It is non-empty because obviously 0 polynomial, its value at 1 by 2 is 0. 0 polynomial at its value at 1 is 0. Therefore, they are equal. Therefore, the 0 polynomial belongs to W. It's a non-empty subset. And it is obviously given to be a subset of V. So, it's non-empty. Right. So, we will show that W is a subspace of V. So, for that, we take Fg belongs to W and alpha beta belongs to R. Fg belongs to W means F, its value at 1 by 2 is equal to F, its value at 1, and G at 1 by 2 is equal to G at 1. And now we test what happens to alpha F plus beta G. Is it also an element of W? If it is a subspace. Otherwise, it is not. Alpha F plus beta G, its value at 1 by 2 is equal to alpha F at 1 by 2 plus beta G at 1 by 2. It is vector addition in the vector space. And this is equal to alpha times the value of F at 1 by 2 plus beta times the value of G at 1 by 2. It is scalar multiplication. And F of 1 by 2 is F of 1, G of 1 by 2 is G of 1. So, alpha times F of 1 plus beta times G of 1. This is alpha F plus beta G, its value at 1. So, thus alpha F plus beta G, its value at 1 by 2 is equal to alpha F plus beta G, its value at 1. Therefore, alpha F plus beta G belongs to W. For all Fg belongs to W, for all alpha beta belongs to R. That is precisely the necessary and sufficient condition for a non-empty subset to be a subspace. Thus, W is a subspace of V. So, therefore, the option C is true. Right? And it is also a straightforward question. And that is the discussion of the solution of the problem, 3 problems from John MA 2022 examination from the section Linear Algebra. I am sure that you have understood the solution of this problem, or the solution of the 3 problems, and I wish you all the best. Thank you.